Sailing, sailing to Lagrange point L2. Oh, are we recording? So I'm singing about the giant solar sail NASA's going to launch in 2014. It's the largest sail ever created and will cover 1,200 square meters, about the area of your average Olympic swimming pool. I'm Sophie Bushwick, and welcome to the countdown. The solar sail, dubbed Sunjammer, will be propelled along by nothing more than light. Photons from the sun will push on the sail, creating the minuscule force of 0.01 newtons. That's a force equal to the weight of a sugar packet. But in space, you don't need much to get moving. And the sail's final destination is nearly 3 million kilometers away at Lagrange point L1. This is where the gravity of the Earth and the sun cancel each other out. Here, Sunjammer and future solar sails could keep watch for solar flares and objects headed towards Earth. The big advantage of solar sails like Sunjammer is they don't have to carry their own fuel, and so they can be much lighter and travel much farther than propellant-based spacecraft. With a big boost from the sun, NASA engineers think giant space sails could one day travel beyond our solar system and even to nearby stars. Can we predict when a star is about to explode? Scientists hope to answer that question by looking at SN 2010MC, a type 2N supernova. These supernovae happen when a star 8 to 50 times more massive than our sun collapses and then explodes. But 40 days before this particular star blew up, it spat out a chunk of mass, 1/100th the size of our sun. Compared to the star's total lifespan, which was about 10 million years, the 40 days between the mass expulsion and the supernova is the blink of an eye. Researchers at the Palomar Transient Factory, the ground-based astronomical survey that made this discovery, say there's a 99% chance the two events are related. By studying the exact process behind the mass outburst, the astronomers hope to predict supernovae before they begin. The study's published in the February 7th edition of Nature. The habitable zone is the region around a star where it's not too hot and not too cold, for life that is. For liquid water, it's just right, hence the nickname, the Goldilocks Zone. But Goldilocks just got a little pickier. Scientists have redefined the region, qualifying as habitable. The new standards are based on updated information about how water and carbon dioxide are absorbed in a planet's atmosphere. These conditions affect whether or not liquid water can exist, and thus support life, on a planet's surface. The new model isn't perfect. Earth itself is teetering at the very edge of the new zone, but obviously we're not freezing or boiling to death. The model doesn't take into account Earth's clouds, which reflect sunlight and keep our climate stable. So, who knows, the new boundaries could be missing other habitable worlds as well. Last week marked the 10th anniversary of NASA's Columbia shuttle disaster, which killed all 7 astronauts on board. But did you know there were actually some survivors of the accident? A few days after the crash, scientists discovered canisters in the wreckage filled with thousands and thousands of roundworms. You might remember Columbia broke down during re-entry into the Earth's atmosphere, but the worms, called C. elegans, were stored in an insulated canister tucked inside one of the shuttle's compartments. Since the nematodes were shielded by several layers, they didn't hit the ground with the same intensity as other objects on Columbia. This is what saved them from destruction. The roundworms were one of 80 experiments taken to space on the shuttle. Along with C. elegans, the mission also carried insects, spiders, fish, and silkworms. The offspring of the surviving worms have since been a part of several space explorations and the subject of various studies and experiments. Spring on Mars isn't exactly the same as on Earth. Instead of ice melting into water, Mars has dry ice evaporating into thin air. During the Martian winter, carbon dioxide freezes into a cap 2 feet thick, covering the sand dunes on the planet's north pole. As the temperature heats up in the spring, the solid carbon dioxide, also known as dry ice, transforms into a gas in a process called sublimation. This springtime activity creates patterns of light ice and dark sand, clearly visible in images from NASA's Mars Reconnaissance Orbiter. So what exactly is going on? First, the frozen layer cracks open to show the sand. Then, dry ice on the underside of the layer sublimates, builds up pressure, and bursts through the top, carrying sand with it. This scratches grooves into the dunes and sprays sand into fan-like shapes on top of the ice. Mars may or may not have life, but it still has plenty of action. And that's your countdown. For links to all of these stories and more, visit scientificamerican.com/thecountdown. The link's in the description below. You can also subscribe to the Space Lab channel or watch another video. For Scientific American, I'm Sophie Bushwick. Until next time, I'll be working on Countdown, the musical.